Okay, now that we know what Boolean algebra kind of is, let's look at some proofs. Now, I promise not to dwell on this any more than is absolutely necessary because I hate math, but it's kind of important for you to know these, considering they're like core concepts of the course, and we'll be using them pretty extensively as we go forward. But, okay, so this is called the consensus theorem. It's like one of the axioms of Boolean algebra, right? So let's try and prove this. So what this says is x times y, or x times y naught is just x. Cool. So let's try and break this down. So we see that there's this x term in both places. So just like regular algebra, we can just pull that out. So x and then y plus y naught. So we have this y plus y naught term here. What this is saying is y or not y. Now, just looking at this, it might not strike you as anything particularly significant, but if you look at this, this is always going to evaluate it true, right? It's always going to be true. Why is that? If you say, okay, I'm going to do that thing regardless of whether or not something's true, right? If I say, oh, I'm going to get ice cream whether or not I'm hungry, that means I'm going to get ice cream regardless of what I do, right? So it's whether or not, right? I'm just going to get ice cream. So that is one of the identities, I guess you could call it. So yeah, so if that's a 1, right, it's pretty easy then to see that x times 1, right? So that's when you add something with 1, this is also another identity. If you do x and 1, this is just x, right? Because this will always be 1. So whether or not this is true, this output, if it's true, then that means that this is also true, right? Because this is always true. So that's kind of another identity. So yeah, x times 1, which just means x. Now let's look at something way more involved. So this is a proof by consensus again. Just the same thing that we used earlier, but this is a lot more involved. So we have 3 terms now. Let's look at the terms. Let's examine them. So this yz here, it has a y from here and a z from here, right? So just by looking at that, you can be like, oh, maybe that makes sense, right? But proving by, bro, look at it, does not really work on the exams. So let's try and prove this by not just looking at it, I guess. So let's first multiply it by 1. Multiply the middle term by 1. As we saw earlier, 1 can be represented, just by x plus x dash, for instance, right? xr, x naught, that would be a 1. That's called identity. That's a property. I'm going to write these properties here as I go along. So let's write that out, and then, yeah, just like I alluded to, the next step would be to just x times xy, or sorry, x times y plus x dash, y times z plus x dash z. Cool. Now we have that. We have this new term here that we can just expand, right? So what do we get from expanding it? Well, by distributivity, we get something like this. So x, y, z. And then plus, because we're getting that plus out of there, x dash, y, z. And then x dash z out here. Cool. Now what do we see here? We see that there's an xy here, right? And this xz here that is being repeated. So what do? We factor. So when we factor, we get xy times, let's see, 1 plus z here, and then plus, this would be x times z, 1 plus y. Cool. Now we have another, I guess, I don't know if this is called identity actually. This would be called null, I think. Basically, when you have x plus 1, right? This entire term just becomes futile because you're just saying this is always 1, right? Because what you're doing is you're ORing something with a 1. If you recall the truth table of OR, when you have something like this, right, and you have something, one of these, it's always equal to a 1, right? It's only if they're both 0 that it's a 0. So by setting one of the inputs to 1, you're pretty much guaranteeing that the output's 1. Anyway, so that makes these two terms go away. What do we have left? X times y plus x dash times z, which is exactly what we had in the question. So yeah, that's pretty involved, I will say. Seeing stuff like this is pretty hard to like get on your first try, but I will say, when you see a really nasty equation like this, splitting it might not be the best course of action always. So I think spamming these x or x naught identities everywhere is usually what works the best for me. But it definitely takes practice. You can find problems online, and there's like calculators that kind of like walk you through step by step way better than I just did. So yeah, use those resources.